Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 5.3.3. Our M&Ms now finally are getting officially into your notes the steps for the 5D process. Okay, so it's a little bit different than the kind of flow chart that I showed you in the lesson, but it's got the basics down, right? Okay, so first of all, you got your problem, and you got to read through the problem. So it says the base of a rectangle is 13 centimeters longer than the height. Okay. So here's a depiction of that. We know we're talking about a rectangle, and we know it's got a base and a height. And so it says that the base, the base is 13 centimeters longer than the height. So what I would do in this situation is I would say, all right, we know that the height is the unknown here that the base is being compared to. So if this is x, then the base has to be 13 longer than the height. So this would be x plus 13. Now we've defined our two parts that we've got. We've got our height and our base, and then we know this is going to be our x, our trial number, and this is going to be our x plus our 13. So we start going through a guess and check process until eventually we get to our answer, or actually I should say to our total, which is 58 centimeters for the total perimeter. But we've got to remember, as we do this problem, how do we find perimeter? Perimeter is always equal to 2 times in this case, we'll call the height plus 2 times the base. Normally, we would say the length and the width, but that works just the same. So we're going to have to take 2 of these and 2 of these, add them all together, and then see if we don't get 58. And in this case, we started off with 10. That was too high because that ended up being 10 and 23. Right, the height would be 13 more than the base. So if that's 10, that's going to be 23. And then 2 10s and 2 23s make 66, which is too high. So then we lower it to 7. That ends up being too low. And then 8 ends up being the winner. Now, we haven't actually started solving this algebraically yet, have we? So I'll just leave it at that. We're still doing the guess and check process. Once we figure out that the base was 8 and the height was 21, then, or the other way around, I guess the height was 8 and the base was 21, then we declare our answer and we can feel confident about solving this problem. All right, so let's take a look at this problem. This is actually a problem where trying to solve it algebraically becomes a problem. All right, so it says if the total area of the rectangle below is 168 square units, how long is each side? To find out how long the x side must be, copy the diagram and table and answer the questions, or the following questions. All right, so we would just fill in the table, right? So we know that the what do we have, base and a height? Here's the base is 2 more than the height. So if I were to say that area is equal to base times height, then I could say 100, no, change the color. Let's do this guy instead. Yes, much better. So we could say that the area, which is 168, has got to be equal to x times x plus 2. So if I want to solve this algebraically, I have to do this. I have to call that x squared plus 2x is equal to 168. And now I've got to go, that's a bit of a mess trying to figure this out algebraically. It truly is going to involve subtracting 168 from each side, so you end up with x squared plus 2x minus 168 is equal to 0. And then we've got to factor this guy. And what 2 numbers can you multiply together to give you negative 168? That when you add them together gives you 2. Remember our diamond problems? The diamond problems were geared for us solving these kinds of equations right here. So I'm not going any further because this is complicated. You're not ready for it. So sometimes since creating an equation and solving the equation can be extremely complicated, you know, sometimes it's just best to go through and do the guess and check process. So if you start with the number 10, this is, remember, this was our x and this was our x plus 2. So 10 and 10 plus 2 is 12. Multiply them together, you get 120. Well, that's too low because we want 168. So we could have jumped up a little bit more and gone to maybe 15, but that wasn't too far off. So I decided to go 11 and 13, but that was 143. So then 12 and 14. gives us 168. So that's what we can declare right there. So describe how the lengths of the two sides are related to each other. The longer side is 2 more than the shorter side, right? And which side of the rectangle does side 2 represent? Side 2 would have to be the base, right? Yeah, the longer side, the base. And then for the answer to it, this is the answer right there that we've declared. All right, evaluate each expression. This is going to be using the order of operations. We've been doing a lot of practice with this recently, where you must take care of parentheses first, then move on to multiplication, and then do the subtraction and at the end. Now, here's an addition problem, but that's inside parentheses, so we must do that first. So I'm going to go ahead and work on this problem, and then I'm going to come down here and solve these. But if you have any questions about the rest of them, feel free to ask. So this is going to be 18, and then half of 18 is 9. 9 minus 4 times 5 is 20, and 9 minus 20 is negative 11. So that's why we have negative 11 for our answer. Oh, maybe I'll do one more. Maybe I'll do this one. So 6 squared literally means that exponent has to be done first. That literally means 6 times 6, which is 36, plus this multiplication has to be done before the subtraction, and so does the division. So I'm going to do this as 21, and this is 3, right? 9 divided by 3, 3 times 7. Take that. Now we're going to go from left to right. You get 36 plus 21 is 57, and 57 minus 3 is 54. Boom, boom. All right. Now, combining like terms to simplify an expression. Find all the like terms and add them together. And remember, the sign in front of the number tells you whether it's a positive or negative. So in this situation, you have positive 2x's, positive 1x, and positive 3x's, gives you 6 total x's there. And then this is a positive 5, and that's a negative 6. So 5 plus a negative 6 gives you the negative 1, and that's how you got that as your answer. Here, same idea. You got, no, I want to color coordinate. I got 1 positive x, a positive x, and a positive x to give you 3 positive x's. And then that's a negative 8 to go with a negative 5 to give you negative 13. And negative 13 plus 1 gives you negative 12. So our final answer ends up being 3x minus 12. All right. A radio station is giving away free T-shirts to students in local schools. It plans to give away 40 T-shirts at Big Sky Middle School and 75 T-shirts at High Peaks High School. If there are a total of 350 students at Big Sky and 800 students at High Peaks, what are the probabilities for each one? So we'll start with what is the probability of getting a T-shirt if you're a student at the middle school. All right, so this is the middle school, that's the high school. Okay, got it. So the middle school is going to be 40 out of 350, which if we simplify it is 4 out of 35. And if we want to change that to its percent, well, let's just go with the original. 40 divided by 350 gives you this decimal number, which would be rounded off. So to change it to a percent, you move the decimal 2 places to the right, and it becomes 11.4. Or you could have rounded it to 11.43, but I just called it 11.4. Now for the high school, 75 out of 800 students, which simplifies down to 3 out of 32. But if you want to change that to a percent, you just take 75 divided by 800. You get 0.09375. So move the decimal 2 places to the right. That becomes 9.3, or we could have rounded it to 9.4. I rounded it to 9.38, right? I don't know why, but 9.4 would have been just as well there. And now, if you're going to compare them, now we can compare them because it's easy to compare two numbers or two portions if they're written as a percent because they have the same denominator of 100, right? So 11.4 out of 100 is greater than 9.38 out of 100. So the middle school is the winner there. They have the higher likelihood of getting a free T-shirt. All right, one student wrote the expression 17 times 102 as 17 times 100 plus 2. Then she simplified it to the 17 times 100, which is 1700, and 17 times 2, which is 34, and got the answer of 1734. Does that work? And absolutely it works. It's a very good way of solving problems mentally is by using the distributive property. Now you could have just gone ahead and done 17 times 102, but to be honest with you, you're doing this very thing, right? You're just doing it in reverse order. If you did 17 times 2 first, oh no, that's not quite the same thing, is it? My bad. This is how we're actually doing it. We're doing it as 102 times 10 plus 7. That's what this algorithm shows us to do, where you start by doing 102 times 7, which is 714. Then you do 102 times 10, which is 1020, and then you add them together to get our answer. So, this algorithm's based on distributive property, even though you weren't taught that at first. And you can do it this way as well. And sometimes by using distributive property, you're able to solve problems mentally. And this one was one of those where you could solve it relatively easily just by keeping track of these two parts in your head. And that is it. That's the end of our homework. All right, let's move on to the next activity.
Hey, feeling good, like I should. When in dark, walk